Water nanodroplets surf the graphene wave, and plants are drugging bees with caffeine. This is Science Wrap. Hi, and welcome back to Science Wrap, the show where we feed you the tastiest new research from the world of science, all wrapped up in an easy-to-digest package. My name's Miriam, PhD and science lover. This week, nanoscientists have shown that tiny droplets of water are able to diffuse faster through a sheet of graphene because of a surfing-like motion. Graphene is a sheet of carbon atoms that are arranged in a honeycomb-shaped lattice, only one atom thick. Just like shaking a piece of paper, this lattice can be rippled through touch or heat. If water is placed on top of the graphene sheet, it can diffuse or pass through it. The droplets sit in the valleys of the graphene ripples, and as the ripples move, so too do the water droplets, just like surfing. It's the coupling of the water droplets with the graphene ripple that makes diffusion happen faster. The higher the ripple wave, the faster the diffusion. So why does this matter? First off, it's important to remember that we're dealing with really tiny stuff. We're talking nanometers, which are a billionth of a meter small. This mechanism of speeding up diffusion through rippling means we might be better able to deliver things like medicine using nanoscience in the future. The other news that's got me buzzing this week is from the latest issue of Current Biology. A group of researchers from the University of Sussex have shown that plants can drug bees using caffeine to make them come back to a particular flower time after time. On the surface, it looks like plants and bees live in a happy, cooperative world.
You ever see pollination up close? No, sir. I pick up some pollen over here, sprinkle it over here. Maybe a dash over there, pinch on that one. See that? It's a little bit of magic, ain't it?
Wow, that's amazing. Why do we do that?
That's pollen power, kid. More pollen, more flowers, more nectar, more honey for us.
But the interests of plants and bees don't always align. For example, bees might want to forage close to their hive, whereas plants might want bees to go further so that they can be the ones that are pollinated. What plants can do in this tug-of-war is to have chemical compounds that basically make bees addicted to them. One of these compounds is caffeine, which is found in about half of all plants. Scientists in this study set up two feeders, one with just pure nectar, and the other nectar infused with caffeine. They found that bees returned to the feeder with the caffeine in it more often, and also pointed their mates in its exact direction using their waggle dance. This meant 4 times as many bees ended up going to the caffeine-laced feeder than the control. This research provides a fascinating example of the ongoing tensions that exist within nature. Coevolution and evolution in general is a constant struggle to adapt and be the best. This manipulation of bees by plants is just one example of this. Now, this week's Science Wrap wouldn't be complete without some mention of Back to the Future. So you can check out how time travel works, or doesn't, in the link in the down bar. That's a wrap on some of the science news for this week. Feel free to subscribe to stay up to date.